So, welcome everyone to another show. Really appreciate you being here. Today's topic is somewhat similar to last week, but it's called Unlocking Entity Resolution with AI, how Fern is revolutionizing data matching. We have our machine learning specialist. His name's Rob Sylvester. He's a senior staff machine learning engineer here at Reltio. How's it going, Rob? Yeah,
Hey, Chris, how's it going, man?
good. I've been trying to get him on a show for a long time now, and here he is. So I'm really excited about this.
Finally made it happen.
We made it happen. This is the day. The rules of the show is the usual. Keep yourself on mute. Questions, push them into the chat or take yourself off mute. We're going to have a lot of questions and we'll get to as many as possible. I've been talking to Rob and also Suchin from last week, and we will be doing a live Ask Me Anything around this topic. We'll just have to get that scheduled because there will be tons, and we'll get to as many questions as possible. We are recording it, so if you miss it or want to go deeper into it, we will definitely make sure you get that recording. Here's some upcoming events. We have a couple more that we've added and that are in the works, but today's show on unlocking entity resolution. We have a show next week on Customer 360 data product, powering AI-driven data unification for enhanced CX. We have Vinky. He's our product leader that will be presenting on that. And then we have some stuff on Reltio Integration Hub. It's what everybody loves. And I'm really excited. Dan Gage is going to be presenting specifically on two shows on enhancing data integration, address cleansing techniques with Reltio Integration Hub. And then on the 20th of June, we'll do one on advanced data enrichment with Reltio Integration Hub. And lastly, 2 days from now, we have our Reltio Life Science event. I'll push that into the chat, the links. If you haven't registered in your life science company, it's an on-site event. That's half day. Really excited for that. There'll be breakfast and lunch and a lot of networking and lots of people talking about some of their implementations and what they're doing and things like that. It's going to be a lot of fun. Really excited about that as well. But let's get to our show. Rob, what do you think?
I think I'm ready.
All right, let's do it.
Take it away. So thanks for having me on here. Chris wasn't lying. He's been trying to get me on here for quite a while. We finally were able to make it happen. And of course, I get sick a few days before it. So you guys, I don't normally have my normal panache. That's what's going on. I'm going to get my screen up here. Let me know when you got it. We good?
Yeah, we're good.
All right. So I was at the show last week. A lot of you guys were at the show last week. And while we had been planning for this for a few weeks now to do this kind of 1-2 punch with Suchin, where we would talk at a little bit at high level, collect people's questions, and then I could dive in a bit more technically. I was surprised at just how many people attended, how many questions there were, which kinds of questions there were. There's a lot of interest in not only entity resolution, but in the underlying mechanisms that we're using to solve it. So what I'm going to do for the next like 20 to 25 minutes is run through a deeper dive, technical deeper dive into Fern, get a little into the nitty gritty. And after that, what I want to make sure to do is try to capture as much coverage as I can on those questions, because inevitably you guys are going to have more of them. And I'm going to answer most of the high level themes that you guys asked about last week. And so what I want to do then is put the questions in the chat. I'll stop 2 or 3 times and talk to Chris and we'll do that. Otherwise I'll just blabber about machine learning for like hours and hours and nobody will ever get anything done. Let's dive in. Most of you know what entity resolution is, but let's talk about it a bit from my perspective. I was brought in for the most part to Reltio to work on this problem. And it is a beat of a computer science problem. This is an example of what I would say nine entities with 3 attributes. And if I sat and I asked you guys to build a machine learning model that could solve this and do it well, it would already be difficult, right? It would already be difficult when you have to consider names, prefixes, suffixes, different alphabet, abbreviations and nicknames, locations, formatting differences, standardization, typographic errors, combinations of different errors. You have to add all of these things up. And there wasn't really a great way to do this. And arguably, even today, nobody's dominating the entity resolution space because this is such a difficult thing to solve. And it may not be difficult to solve when you have, in this case, 9 entities with 3 different attributes. But what if you have 100 million entities or billion entities? What if you're trying to resolve or deduplicate match pairs of individuals in the United States, and you have a U.S. Census data and you have 300 some odd million people, and these people have not just names and addresses and emails, but they have phone numbers and they have multiple addresses and they have Social security numbers and different identifiers, birth information. You have all this that spirals out of control very quickly. Most of the players have tried to solve this with traditional matching techniques, string comparison, edit distances. Some people start to throw in phonetic distances. If this word sounds like this word, and it gets you some of the way there, and they work pretty fast. But that landscape has changed a lot in the last 2 years. And for somebody like me that's been doing computational linguistics for most of my life, when I see this problem, I thought to myself, I'm going to make something new. And so last year, basically on weekends, I sat for a few months and I built what I call flexible entity resolution networks and brought it to Reltio, and it started to take off for reasons that I'm going to demo to you guys today, because what it does is it allows us to not sit there and try to code out all of these little rules around which words sound like this word, which characters in this language map to this language. What if this guy has a vacation home? This guy has another home. What if this guy's formatting on his email is different than this email? What if it's a work email? What if it's a phone number? What if that phone number has a country code? All of this stuff, and it just balloons out of control. And these are the kinds of things that machine learning is good at, right? Really good at. And that's why we went down that direction. So I wanted to kind of preface what I'm talking about today with that, to let you know the motivations for it, but also to capture for those of you that didn't catch the show or are new to this or didn't see the show last week, that's the motivation. How can we deduplicate at scale across many different sources of variation something like 2 humans without creating tons and tons of these rules? But a technical note then. There are 2 steps to entity resolution. We didn't touch on this last week. I want to touch on it now. Grouping together candidates is something called blocking. We're not talking about blocking today. Inevitably, I will probably be back here with Chris sometime later this year to talk about blocking. But blocking is the step where we go in and we find the good candidate to send to our machine learning model. We have 100 million people. We can't compare 100 million people against 100 million people. That would take thousands of years on a machine to do. So this first step in entity resolution is called blocking. That's not what we're going to talk about today. If you have questions about blocking, you can send them to us and try to answer them now or later, preferably later. Fern, though, is an object comparison model. So Fern, and most machine learning models, and really in the academic definition of entity resolution, what it is, it's the second step. It's the step that says, okay, take, for example, Rob Sylvester in San Francisco over here and Robert Sylvester in San Francisco over here, similar email. Those would get blocked together and the machine would say, okay, these are similar enough that they should get sent to Fern. It's a high recall, low latency process. Whereas step 2 here is a high precision, higher latency process, right? You'll get the candidates first and then spend the bulk of your time on whether or not they're good. So let's dive in. What happens when we have many people to choose from? How do we, for example, and I'm going to run with the example of people today, because I think it's one that most of you guys are trying to solve with your data sets. Most people have data sets of people. If you have let's say just names together, Rob Sylvester and Rob Sylvester. That's a pretty easy one. You probably don't need the fanciest machine learning model in the world. If you have a misspelling, you maybe don't need the fanciest machine learning model in the world there either. Maybe a perfect string comparison wouldn't catch it. If you throw in middle name, things get a little hairier. Some of those edit distances won't work out. You can look at substrings and maximum kind of variation. You throw a nickname, things get a little more complicated. We can start to throw a nickname dictionary. Those are fun. They don't have the greatest coverage in the world, but maybe you can download a bunch of nickname dictionaries off the internet and try to get them. You start throwing in different alphabets, transliterated alphabets, and all of your edit distances break down. Your phonetic edit distances break down. That becomes a little more difficult. You have translations that happen. You have different, I lived about half of my life down in Colombia, and a lot of people call me Bruno when I'm down there. That it's a source of variance that I'll be honest, I underestimated, but it does exist, especially from on the end of people that do data entry. And then you have, of course, the false positives, names that are pretty similar, but they actually are not the same person. And then you have something that should actually get blocked out of the way. So the question is, how long do you want to sit and spend to try to code up these rules? How are you going to capture all the nicknames, all the phonetic barriers, all the typographical errors, standardizations, formatting, different languages? In Latin America and in India, people tend to have multiple first names and last names. In Japanese cultures, last names are listed first before first name. All of these sources of variance are going to pretty soon things get out of control. And this is just name, right? This is just first, middle, last name. Try throwing in another 10 or 15 after. So to me, what I saw when I tried to start working with this problem, I said, what if I had a machine learning model out there that had just seen all of this stuff, that had seen in its training data nicknames, that had seen different alphabet transliterations and alphabetic variants, that had seen different versions of names depending on the country where the person is, that had seen formatting differences, that had seen common misspelling. Those models exist. They're called large language models. We don't think about them necessarily in that way. We tend to think about them in terms of which words appear in the context of other words. But you know what? Misspelling often occur in the context of the correct spelling of that word, the same kind of context. And often words in different languages tend to appear together in the same way. And phonetic variants and nicknames tend to appear in the same context. And when I made this realization, I thought, holy hell, if we get the prompts right and we find the right way to capture and ask these probabilities the right way, we can capture all of this right off the bat. And our customers don't need to come in and code rules for any of it. We don't need to go in there and say this edit distance, this fuzzy match, first name exact, last name exact, transliterate this name, approximate distance on first name can be this, look up this nickname table, get it all and get it for free. And that's what machine learning models, modern machine learning, generative AI models are good at, if you use them the right way. Now, maybe that's not super clear with something like name, but tell me how you are going to differentiate two product descriptions on Amazon. Paragraph long product description. How are you going to get that right? So this is where entity resolution models with modern AI, large language models, transformers, sentence transformers, these kinds of vector-based representations of text tend to shine because they're unlocking patterns that we haven't been able to code for traditionally. So under the hood, Fern is built almost entirely with large language models and these different kinds of transformers. Chris, do we want to stop and ask any questions before we start diving into the real nitty gritty?
Right now, let's just dive in. There's no questions. I think you got people
Good.
just waiting.
Okay.
Hey, I have one question. While we're talking about like person,
Yeah.
is this subjectable to organized as well?
Can you repeat that?
And we are discussing about the person entity. That's what
Yeah.
I'm asking. Will this be applicable to the organization as well? Whatever. Yeah.
Yeah. So an organization model, it tends to not be super important. We won't talk too much about the organization Fern model. There is an organization Fern model, by the way. I'm not sure if that's been publicly announced, but there you go. And it turns out that the context for the organization model is not super important in differentiating whether or not two organizations are the same. Maybe for some customers they are, but the same strategies are used, right? Like a contact point could be Rob Sylvester for this organization. But the same strategies can be used, the same kinds of prompts, the same kinds of, the organization name itself can be treated the same way as what we do here with a person's name and try to compare two organization names in that way. That's a good way to think about it because it is similar. The prompts are different and some of the features are different, but it's a high level.
Quickly, I would think that the first example is actually really hard, but looks like the same person, but two different people. So we'll probably get there. You'll show some of that. Okay.
Yeah, absolutely. All right. So let's dive in a little more on if it wasn't obvious, by the way, I'm not a designer. I'm definitely an engineer. So if you're wondering why I'm like slides and my colors, like really stupid, it's because I made them. We'll have to deal with that. We'll be engineers today, all of us. So here's an example of what a large language model gives us. If I look at the attribute for an entity, Reltio entity, prefix, first name, middle name, last name, and suffix, and I put them all together, Dr. Sarah Jackson Jr., something like that. And I say to myself, how similar is this person, this group of attributes put together to this other person? So if I actually load this in the Fern, I'm not talking about an entity model, I'm talking about give me a large language model representation of the similarity between this name that I'm showing here, and name one prefix that Alexander Ivanov in Cyrillic and Russian. And how similar is that name to this candidate, right? And the first candidate is Dr. Sarah Jackson. Now I've redacted the suffix. I'm not going to give you guys how we prompt these things. I'm also not going to tell you how we turn them into scores, but because obviously if you guys run things like ChatGPT, you don't see numbers come out, right? Words come out. But for anybody that works with these models, you know that what they actually do under the hood is they give you probabilities of words. You could pull out those probabilities and do things with them. Now, this is when the moment hit me last year when I said, okay, this is power. I was messing around with these models and I said, I'm going to take this name, Alexander Ivanov, and I'm going to slide it from a name that looks nothing like that to a name that looks a lot like that. And I'm going to ask something similar to how likely is it that these are the same people? And you can watch these cases. If you look over that table on the right, watch what happens. Sarah Jackson sort of transitioned the name from being an American name, female name, Russian name, Russian male name. And you get that distribution that tends to reflect that proximity, that semantic proximity. It's capturing a lot under the hood here, capturing gender under the hood, capturing phonetics. It's capturing frequency. It's capturing nickname under the hood. This is a powerful realization because it means that you get something for free that would probably have been very difficult. If I were to ask you guys to make a machine learning model that can give you this sort of distribution, the smooth, real distance that looks like or behaves the right way, this would be very difficult to make. And large language models give you this if you use them the right way, almost for free. Now, does it work with other attributes? Yes, of course it does. These things are trained on reading most of the internet. So I grew up in Juneau, Alaska. I don't live there anymore. And I said, let's give an example of an address object. And we'll slide, for example, an address in Juneau, Alaska, 123 Depression Boulevard. And we will transition that to some address in Baltimore. And you get the same distribution. If there are these two addresses referring to the same location, that's not the actual prompt. There's actually a few different tweaks under the hood, and I can get into them, and I will get into them a little bit, but some of these things are patent pending, and I won't get into them, but I'll answer the best that I can. The important part here is to realize if you look at this table, you get the same thing. You get the same sliding distribution to go from something that's nowhere close to very close. And the nice thing about a distribution that works well is we can use these as attribute scores. We can, as data stewards, set a threshold and say, okay, show me 80%, show me 70%, show me 90% on something like address. And you can get something that behaves the right way. So I'm going to stop here again and ask, see, our 10 or something chats popped in. Chris, do we have anything pressing or similar questions people are asking?
We do have several questions. Let's get to a couple of them. There's some thumbs up on this one. Is the primary use case for this to operate in a batch mode, like a warehousing environment, or can this be leveraged in a real-time environment where you have to compare incoming transactions to an existing data set of millions of records and find the match in real-time search before create, like SBC?
Yeah. So we'll get to this in a little bit, but basically the flexible part of Fern, flexible entity resolution networks, are the switches on that trade-off. A lot of it is the switches on that trade-off of how big of a model are we running? Are we running this in batch where we don't care if it takes 500 milliseconds to resolve an entity? Or are we aiming to use smaller LLMs, smaller sets of features, smaller number of slices, those kinds of tweaks so that we can get a much, much faster result? So the way that Fern actually works is it takes all of these different, let's call them features, right? These LLM features, as well as a few that are not LLM, and combine them together to make one score for an entity. Now, the way that combination works is very customizable, very customizable. We can do fast. We can do really slow, but more accurate. We can do it for this entity. We can do it for an organization entity. We can do it for single attributes or groups of attributes. We can do it for some customer that comes to us and says, I have a very specialized use case. The reason we call it a flexible entity resolution network is because unlike a lot of traditional machine learning models, this address feature that I'm using here, I can pick this thing up and I can throw it at, for example, two organizations, because it's a Reltio address object, right? It's standardized. An address, two addresses are two addresses, period. Whether it's addresses for resolving some guy's work or two organizations or where some piece of mail is going. And a large language model doesn't care, and an entity resolution model doesn't really care. So that sort of plug and play modular approach is a lot of where the flexible piece comes in. Do we want to answer one more?
Sure. Are there any benchmarks done on what the traditional ones couldn't do, but this new framework using LLMs will have either solved or increased the accuracy of resolution? So with the largest data set?
Yeah. So we run a lot of our benchmarks on real data set. They have partnerships with customers that we're able to actually look at, but I'm not going to show you guys like customer data set scoring metric. But basically the way that we look at this is under two lenses. One is like aggregated total on match rates and consolidation rates, latency, projection cost, things like that. And then the other one is specific catered types of matches for things that people have traditionally struggled with. And people have traditionally struggled with non-English characters, for example. People have traditionally struggled with nicknames a lot, with nicknames. People have traditionally struggled with long text description, like product description. People really struggle with that. Organization name, people really struggle with that. So what we do is we end up building out like specific evaluation data sets around just those. And we try to solve them with Fern or large language models or whatever. And then we also try to solve them with traditional string matching and whatnot. And that ends up being what motivates us to use the LLMs, because with something like a product description, you just can't get anywhere with it.
Rob,
Fuchin's here. Hey, buddy.
yeah. So
Yes,
basically,
jump in.
one other way to look at this is, imagine you have a pile of potential matches, say 20,000 potential matches currently sitting in your queue. And if you enable Fern, what we have seen is it does provide a score for every single potential matches that you have there, 20,000. Your data stewards are required to go through every single one of them to resolve and spend time on every single pair to decide whether it's a match or not a match. What Fern does, it provides a score for those potential matches. And now suddenly you have 7,000 of them getting a very high score. Now your data stewards can go after those records first, and thereby basically improving your productivity of your data stewards, right? So that has been one of the popular use cases with our early adopters, that for the existing match pairs, you get to segregate them and go after the ones which Fern thinks has a very high chance of getting merged. And on the flip side, the ones which have generated very low score, you can look at them as well and quickly mark them as not a match. So you can clear your potential matches queue pretty quickly, right? So that is another way of looking at that, the benefit of enabling Fern right away, whether you are in early stages of the development or you're already in production.
Excellent. Let's tackle a few more slides here and then jump back into questions here in a bit, because I was looking at a few of them and I think I'm going to capture some of this stuff on the next couple slides.
Perfect.
How does it actually work? You guys asked this a lot last week. There were about 5 to 6 questions on what are the actual features, what are the actual models, what are the actual LLMs, what are the actual, and I'll try to answer that here without giving away what's patent pending. So I'm not going to tell you which LLM, but instruction tuned LLMs are used for Fern. If you're a data scientist guy, instruction tuned LLM is very useful because they're really good at answering new kinds of questions, right? They're basically made to answer questions that they haven't seen before. And that's very useful for something like entity resolution, because chances are these LLMs weren't really specially trained to resolve entities. But an instruction tuned LLM is going to be better at it than ChatGPT. We can't really take the word probabilities out of ChatGPT, but even ChatGPT does not actually do a great job at being used to resolve entities or resolve scores, which is strange. A lot of people think, oh, ChatGPT, that's the best one there is, right? No, it's not. There are LLMs that are a lot better at it. And which LLM you choose is quite variable as well. So one of the questions was, how do we sit in that performance versus accuracy trade-off? Some people that want to run in batch, you can use a much bigger and slower LLM. Some people that need real-time performance, you can run a much smaller LLM, or you can even make small neural networks that approximate LLM, which is something that we've applied for in patent. And I'll show a little demo of it a little later today in this presentation. On top of the LLM, there are other features, sentence transformer features. Sentence transformers are like LLMs. They're modern AI models that read pieces of text and they output numbers. And those numbers represent everything from how the text is written, syntactic, morphological stuff, to what it needs, the semantic stuff. So these are very useful because some sentence transformers are very good at things like different languages. And some sentence transformers are very good at things like long pieces of text. So product description can be very useful if you add in some of these additional machine learning models. So the way that Fern works under the hood is that we have a combination of several of these LLMs that are delicately prompted, some of these sentence transformers that swap in and out based on the entities, based on the languages that are used, based on the length of the text that are used, based on the performance characteristics that we need on how many requests are sent. And we do still have a few traditional simple machine learning features, things like edit distances, but not many. For the most part, those get turned off. So what happens then is I've showed you guys like a full name model when we slid two names back and forth and said, okay, Sarah Jackson and Alexander Ivanov, 84%. Great. And we have an address that, okay, there's an address in Juneau, Alaska. There's an address in Baltimore, Maryland, 63%. So we're going to get, for example, let's consider it an individual entity. Person has a name, person has an address, person has a phone number, email, all that. So what do you do when you have different scores for basically these attributes? Name score, some number, address score, some number, phone score, some number, identifier score, some number, email address, some number. That's not super useful. You need one number, right? You need one final number that tells you entity A, entity B, are they the same thing? There's a final model that Fern uses when this is where most of the customization and work going on right now is in this custom scoring model. These earlier pieces are pretty interchangeable. We can swap them out between organization entities, HCP entities, HCL entities, product entities, attribute models. It doesn't really matter. But how we combine them together to make one entity score is pretty critical. And there's a reason for it. A lot of people have asked us, if you have an address and you have a name, can't you just take like a weighted average of those two things? Right? Let's say we had a model for humans and we said the name was 50% and the address is 30%, average them out 40%, that's the score. But turns out that doesn't work. It actually fails spectacularly. And the central theme of machine learning, most of the reason we do this stuff is because weighted averages don't work, because we want to find patterns that we can't find before. And it's really hard, not just in Reltio, but anywhere. It would be really hard to take something like a name and an address, just those two, and combine them together to make a score with just rules, with just weight, for example, to say, okay, fuzzy address plus fuzzy name, or exact name plus fuzzy address, or score on address is this much, name is this much. A machine learning guy, an academic, will tell you that's simple. You can't fit a curve. And so what we decided, Fern, last year was instead of asking customers to come out here and give these weighted averages and say, okay, I want the name to score this much. I want the address to score this much. The phone will score this much. And then in these cases, the phone will switch back to this much. Pretty soon you just have a big old bowl of soup, a whole bunch of if statements, and it spiraled out of control. So what we decided was we would do all that for you. We would put a model on top that would take all of these scores and give you what we think is the best single score, because it can do things like represent simple curve. And that's what this horribly drawn little pink line here is. And I realize this is a bit technical, but it's a very important piece to understand as data stewards and as anybody working on machine learning for entity resolution, is that you will not fit a curve with a bunch of Boolean logic. You will not fit a curve with a bunch of weighted averages. You will not fit a curve with a bunch of linear models. This is why, in a sentence, this is why machine learning is used for entity resolution. It's to approximate a really difficult space. This is 2D. This is addresses and names. Throwing phones and emails and identifiers and birth dates and all of that curve is really complex. And you're never going to code for it. Even if you spend thousands and thousands of lines of it, if, else statements and wait, you won't do it. I want to get your guys' opinion. on that, I want to say to you guys, and this isn't a rhetorical question. I actually want to get somebody's opinion here. Where would you score this model? These two people. And then, by the way, this is not entirely me. I do have an Alaskan phone number. All Alaskans are 907 phone numbers, by the way. A large language model would know that for what that's worth, but a non-Alaskan might not. We also almost all have 574 social security numbers. And that's also not my social security number. It's also not my birthday, but it is my birth year. I would want to know, if you were a data steward, where you would put this. Where would you want this to score between 0% and 100%?
And post it in the chat.
Rob Sylvester. There's probably not a lot of Rob Sylvesters out in Medellin. I've never met one. Sylvester's the common name. Got the same phone number. What's the likelihood that somebody has the same phone number and the same name? Phone number is a very good identifier, right? But at the same time, look at that birthday. The birthday is different, but the birth year is the same. And the birth year is the same. There's a 1010. Then you start thinking, I've signed up for a bunch of free trials before where I just put in my birthday as January 1st because I don't want to actually give them my birthday. A lot of people do that. Large language model knows that because it sees it a lot. It also says sometimes formatting differences can be there. Maybe the person really meant 1010 when they wrote in 11, right? The addresses are nowhere close, right? But what if the guy lives in two different places, right? Now imagine trying to code all of that in. Imagine trying to put in all that placeholder info, abbreviations and nicknames. Rob Sylvester in Colombia, and people there tend to have two first names and two last names. This person doesn't. First name, middle name, last name. Typographic errors, country codes, formatting codes. SFNs, those don't really exist if you're in a different country. Frequency statistics on the names. How popular is Sylvester is the last name? Popular. There's actually another Rob Sylvester where I grew up in Alaska. This guy.
So
code for all this?
So all the scores are 50%,
Hold on.
65, 70. Yeah, it's all over the place. Go ahead, take a look.
And that's the other piece I want to talk to you about. It's all over the place. This is a tough task. And what one data steward thinks works, another data steward might not think works. Or what another company has a different profile. Some companies say, I need more than anything to not miss matches. We lose revenue for every match that we don't make. We want precision. What do? We would want those scores higher. We boost them higher because we want the data stewards to see that threshold. Other companies would say, well, overmerging is a major problem for us. You put those scores too high, that costs us money. You got to do that unmerge. It's like a bank or something. Put two people together and they're not actually the same person. That's a nightmare, right? Not only do we have subjective opinion on this, and those opinions vary by a little bit, but the actual use cases for the places we work are different. So what I've done is I've thrown this in to Fern, and I want to throw one more thing at you before we jump into this live demo and spend the rest of the time doing questions, which is that, look, the way that we build these models, and this is another piece that was the patent pending, is that we generate examples. We generate scenarios. We evaluate on customer data based on people that have these partnerships with us. But when it comes to actually building up the models, training the data, labeling it ourselves, saying, does this look right? Does this not look right? We actually generate synthetic data. There are a few reasons for it. The main reason is we can do whatever the hell we want with it, right? It's very difficult when you have customers in all different clouds. Some say you can train on their data. Some say you can train on it, but not evaluate on it. Some say you can train on it, but only we can use it. And then some say you can train on it, you can use it, anybody else can use it. But when we leave, if we leave, then you got to pull away that data from the model, right? You have all of these different scenarios, and it just becomes a little easier to just all work on the same page. So we actually use synthetic data that tries to capture scenarios. I think scenarios, something like name's the same, email's not, phone number's not, and then the city's not the same. You say, okay, what's your score going to be? Now, the reason we want to do something like that is because then we could pass these examples to you guys and we could say, where do you want these scores to be? And if you score them differently than somebody else, a whole lot differently than somebody else, and we say, okay, maybe this company gets a different model head for the individual entity. When I say model head, I'm talking about the scoring model here. If you got a use case that's so different, and you guys agree that some number should be a 0.8 and somebody else says it should be a 0.5, that's different enough that maybe you deserve a different kind of model. But we don't have to reinvent the universe there, right? 99.9% of that model is already built. It's just how we fit those little curves in your use case. That's something a lot of you guys asked about last week, about that customization. A lot of you guys asked about that customization. Some guy's entity model and somebody else's entity model might be very different. And not just in with respect to how those curves are set, but the performance profiling. How fast do you need it? How many LLMs do we use and how many smaller LLMs do we use? Smaller transformers do we use? How many slices do we use? What happens if you have 5 different first names and 7 different addresses, right? You got to compare all of these things. So under the hood, Fern actually has variable numbers of sampling and slicing algorithms. They're deterministic for what that's worth, but it's an important piece to capture, because a lot of you guys asked about that last week. What about it? What about slicing? What about permutation? So if you're looking at this and you're a customer and you say, I've been struggling with taking 2 individual entities and getting a good score on them. I've been struggling with these 2 product entities. I've been struggling with these 2 organization entities. I've been struggling with these 2 location entities, and I keep making these rules. I get a little better coverage. Something goes up, something goes down. This is what you want to be on the lookout for. When we start GAing multiple models, multiple entity types, multiple attribute models for Fern, try these things out and see what you think. Because make no mistake, this is where the space is going, right? Everybody is starting to use. I started building this about a year ago. Look at AWS entity resolution. Look at Google's entity resolution. Look at large language models being used for entity resolution. This is where entity resolution is going. Make no mistake. This is where almost all software is going, right? And when you build these models, it becomes very clear why. But maybe it's not very clear why if you just use these models. But once you guys start to use them, you'll start to see. Now, I don't know if we're going to have a lot of time for that. I want to dive into kind of a demo with this. Yeah. But I also want to get some questions. So let's play with the demo real quick. And then maybe while I do it, we can fire away some questions. Like I said, I'm not an engineer. I'm not a product guy. I don't make PowerPoints. I'm an engineer, and I'm going to give you like the nitty gritty and show you what Fern actually does on my local machine. So remember that model, or that example I showed you, the 2 Rob? Yeah. These guys. I said, what does this model say? I'd be curious. If I load this one up, and that's what's loaded here on my screen. Sorry, I got to move send it to myself. The model score is about 79%. And this is not a full Fern model. It doesn't fit on my laptop. Like I said, there's a lot of different ways we do it. So there's a few smaller transformers, a few bigger transformers, but it's the same example. So we score this and say 79.8%. On top of it, it says, here's a bunch of different scores. Notice it's 0.5 here because there's some missing information, like the email, the identifiers, and 0.5. Is there 0.5? There's no common identifier here. There's no common email. So 50%. That makes sense. Right? Rob Michael Sylvester, R Sylvester. Oops. About 86%. City, Medellin is definitely not San Francisco in many ways. So that's nearly 0%. On top of that, You also have explainability built into Fern. We haven't released a lot of it yet, but this actually literally gives you an explanation of what these individual scores were and where they rank, generally speaking. I know that that's something, I'm not sure we've even announced that either. You guys are learning a lot of fun new stuff today, but that's one piece about generative AI that's nice, is you can turn these things on and you can actually ask for reasons as to why certain scores are made that way. So it's not just about these scores being right. Sometimes it's about, like I said, it's about how they behave when you slide them around. So I thought what we could do is we could toss in a few things. We had R Sylvester. Let's put in like RM Sylvester, right? So that would be the equivalent of comparing these people. Or we can try something else. You guys can shout out if you want me to try it, see what happens. We boosted up. We boosted up to 83.4%, right? And the name score boosted up. Obviously, all the other ones stayed exactly the same. Cool. What happens if we should take a different social security number? What was the last 74, 1, 2, 3, 4, 5. Let's put in 574. Maybe 6, 5. Drops to 56%. That's a weird one, right? This is one where I would want to get your guys' opinion, because it doesn't make a ton of sense that somebody would have the same phone number, the exact same phone number, the same name, or very similar name, but not have a different social security number, right? There's almost no, if I saw Rob Sylvester, same phone number guy in Colombia, Rob Sylvester, same phone number guy in Kansas, this life, it's probably the same guy. More than 50%. Most of us agree. You don't have to look at these scores. If people say 60, some people say 70. But if the social security number is different, then you'd say, not sure about that one. Fern says 56%, or 56% here. Part of what you want to do when you make these models, obviously the use case is entity resolution, but another really good use case, I think, is, even if you don't explicitly code for it, is to find weird data, find anomalies, find things that aren't behaving correctly. And to me, this is an example of a piece of data that if I was a data steward, I'd probably want this to be verified by a human. And so I'd say, who is this guy? The same phone number, Rob Sylvester, you've got 2 different social security numbers. What's going on here? Probably an error in the data, right? That's kind of use case that actually maybe don't get if you try to explicitly code for something with rules, because you're not searching for that. It's something you get for it when you approximate a space instead of trying to rigidly poke at it and grab it, which is what you do when you build rules out for something. I want to check, quick time check. We got 8 minutes. Let's try to slam through as many questions as we can. I know there's 80 in here. Yeah.
Let's do it. So I understand we're focused on individual entity resolution. Can the technology be used for business names and addresses? I feel like you might have covered that.
Yeah, we can. This model itself actually has an address model sent in on it. Individual address model. In this case, the score is really low. We're talking about metagene, but it can change it to something else. Ask me another one while I do this.
Does the model require any initial configurations, so trainings, or is it ready to deploy for life sciences data?
For life sciences data, the HCP one is almost built. We got some features around like education and taxonomy that need to be tweaked a little bit, but otherwise it's pretty similar. You can use it. You could use it. Actually, there is an HCP model built in here. I'll just undo this real quick.
Nothing like real time. I love it.
This one scores 24 on this HCP. It's a smaller model. Oh, it doesn't have the approximate. So this one doesn't have the phone and the email in there. But it believes, at least on this one, because there's no education, there's no degree, there's no taxonomy, that these people are likely not the same person. It's HCP data. Does that make sense to me? 25, that might be a little low. But at the same time, if you have no other information, what's the name of the HCP? I can't remember the name of the HCP model that has the phone in there. email them. Maybe it's HTTP approved. But anyway, the question was about life science. Yeah, so the HTTP model is pretty much, it'll be ready to go as far as configuration. You can probably customize like basic performance stuff. If you want the big dog or if you want the smaller one that runs faster. And that goes back to the batch versus real time question. Most of the people in life sciences care about accuracy, less about performance. They go for batch models. They just want something very accurate, run it overnight, come back in, result the matches in the morning. Most of you that I've talked to, any data stewards in life sciences, are on that page. So when that gets deployed, anybody that wants to use it, like, feel free.
Yeah, so getting semantic proximity without additional attributes such as like gender, which is many use cases are not available, could be a powerful thing. Sorry, that's just sorry.
It is. It's very powerful. Very powerful. That's one I didn't list either. There are a lot of names where the semantic proximity is like the LLMs are able to realize that it's seen that name in multiple gender contexts. Try finding a data set of that, loading a rule in for it, that stuff.
Several questions around this. Is Fern like a plugin, or can we use it with our existing MDM solutions, or is it something that needs to be set up and turned on in the initial stages and configuration architecture? Sachin might be the best to answer this. I don't know.
It's probably the best for it, but from my side, it's an API call. You go out and instead of hitting some other pre-trained model, instead of going in the Reltio matches and going to go point at this, it's just going to point at Fern, right? And Fern, all it's going to do is look at the two entities. It's going to give you a score back or write a score somewhere, right? That input output is the same. Sachin, do you want to give a more detailed answer?
Yeah. So there is no additional configuration. It is just the enabling. It's a package matching method. Once enabled, you just have to basically say, okay, run my match pair on Fern in addition to the existing match rules that you might have. So there is no additional configuration. The only thing that you might have to do is map the attribute. So in our Fern model, if you have called first name and you're calling it something else, you just have to let us know that your, say, first names plural is same as first name, those kind of mapping. But other than that, there is absolutely no configuration. It is just enabling the model.
Great. Can we use Fern externally via API request, for example, in Score Matches API?
It's run right now within Reltio matching engine. So
I can answer that. So the question is basically we have existing API that returns the score. So we have integrated Fern into that core matching engine. So all your existing API will work with Fern as well. So if you say, give me Fern-based matching on this pair using existing APIs like matches or scored API or transitive matches, all of those APIs are compatible with Fern as well. And there is no additional configuration.
Provide some example of response rate on 5 million organizational database, for example.
At the top of my head, no. We ran mass rebuild for consolidation rate on 2 million entities, and they ran in, I want to say, a few hours, but it was on one model head with, I think we had the cache turned way down. Obviously, these models, they have cache. We're not going to run the same thing 500 times. John Smith. And I want to say ran in a few hours, and it was 2 million with 10 million comparisons or something like that.
And it depends on your tokenization scheme, right? So if you have a large number of common entities to be compared, it's just going to take a little bit longer. But on a typical data set that we have seen, the performance is in par with the rule-based matching that you see today. So there is no additional time that is required for Fern-based matching. And that's what we have seen so far. And there are a lot of optimization that Rob and team is working on. We want to make it even faster than the current approach that we are taking, right? Because it can do in future blocking better so that we don't have to go and unnecessarily compare Sarah with Alexander in that example there, even though they have no same last name or same address or phone number or whatever it is, it will be much better. So it will have a more accurate matching candidates to compare with. So the performance will be even better than what we are seeing today.
Great. Unfortunately, we're out of time. So it sounds like if the two of you are open to doing an Ask Me Anything, because we have literally 20 plus questions in this one and the last one, I can capture all of those. And in the next few weeks, we can do a live session on Ask Me Anything with both Suchin and Rob, if that's possible. Yep.
Yeah, I'm 100% down for it.
Great. Thank you everyone for coming. I'm going to have to stop us here, unfortunately, but please give us a rating and maybe some other thoughts around some shows after you leave so that the Zoom pops up with a rating and your opinions. But thank you everyone for coming. Lots of great questions. Great job, Rob, on this. This is really cool. Suchin, thanks for some input there as usual. Everyone, thank you so much. We'll see you in another week or so. Thanks everyone.
Thanks guys. I really appreciate everybody jumping in to nerd out with me.
That was awesome, man. That was really awesome. I enjoyed it. So lots of stuff we need to still cover or answer, but that's good.
I think so. Let's do that. Let's do the Q&A session. I think that I'd really like something like that.
Yeah, I figured you might. All right, everybody, take care. Bye-bye.